So, welcome back students and myself Chandra Prakash, welcome back to my class and today's a very important topic, that is also electrochemical cells and batteries. Today we are going to discuss about, this is Ask Engineering Academy Dilsukhnagar, which is providing a lot of insights to the students, especially for technical courses and not only technical, for life sciences students also. It is a plays very important role in the upliftment of their careers. And today we are moving on to another topic, important topic, that is electrochemical cells, which is sub branch of electrochemistry. Electrochemical cells, electrochemical cells, electrochemical cells and batteries. Electrochemical cells and batteries. So in this we are going to discuss about what are electrochemical cells, what are batteries, and these kind of information you will get in this topic especially. First, definition. Understanding definition is very important. Definition of electrochemical cell. Definition of electrochemical cell. Definition of electrochemicals. What is mean by electrochemical cell? Simply, electrochemical cell is nothing but it is a device, or it is an electronic device, or it's a device generally generates electrical energy from chemical energy. That means electrochemical cell is a substance or the device that converts the chemical energy into electrical energy. So simply, definition is it converts chemical energy into electrical energy. Electrical energy by series of chemical reactions. By series of chemical reactions. By series of chemical reactions. So the conversion of chemical energy in electrical energy by the device called as electrochemical cell. So electrochemical cell is a basic definition is that the device that converts the chemical energy into electrical energy by a process of or series of chemical reactions. So next, how the electrochemical cell look like? I will give a diagram for this. See, for example, this is a cell or a vessel. This is, look, for example, this is a solution. This is a solution called as electrolytic solution. This is a diagram of electrochemical cell. It is a basic diagram. Electrochemical cell. Electrochemical cell. This is the vessel. This is electrolytic solution in which these are electrodes. These are electrodes. These are electrodes like this. This is electrolytic solution. Electrolytic solution. These are electrodes. These are electrodes. These are electrodes which are joined by voltmeter. Here voltmeter will be there, V. And again these two are joined by salt bridge. This is salt bridge. Salt bridge. Salt bridge contains KCl. KCl solution, potassium chloride solution. They convert it salt bridge. And this is all about electrochemical cells. So for example, this electrode is zinc, this electrode is copper, this electrolytic solution is zinc sulfate, this electrolytic solution is copper sulfate. So these two are for example, actually this diagram will be looks like this. For example, this is one beaker, this is one beaker. In this one electrode, both are joined by salt bridge, and these two electrodes are joined by voltmeter. And this is a zinc solution, this is copper solution. This is the electrochemical cell. So the electrochemical cell will be looks like this. So this is all about electrochemical cells. Electrochemical cell is nothing but it is a cell that produces electrical energy by conversion of chemical energy. So this is electrochemical cells. Now classification of electrochemical cells. Electrochemical cells are mainly classified into electrochemical cells are mainly classified into 4 types. 1, 2, 3 and 4. First, First classification electrochemical cells, first type is galvanic cell or voltaic cell. Galvanic cell or voltaic cell. Voltaic cell. Second one is electrolytic cell. Electrolytic cell. Third one is fuel cells. Fourth one is rechargeable cells or non-rechargeable cells. Rechargeable cells or non-rechargeable cells. So electrochemicals are nothing but there are four types. One is galvanic cells or voltaic cells, electrolytic cell, fuel cells or rechargeable cells or non-rechargeable cells. These are the four different types of electrochemical cells. First we are moving on to galvanic cell. What is meant by galvanic cell? First, galvanic cell. So in the syllabus, especially the galvanic cell is mentioned. So we have to understand what is meant by galvanic cell. So galvanic cell is nothing but it is an electrochemical cells. These are the two beakers. These are one electrode, is another electrode. Both are connected with a salt bridge, and these are again connected with voltmeter. This is voltmeter V, like this, and this is one solution, electrolytic solution. This is another solution, electrolytic solution. So this is galvanic cell. Galvanic cell is one of the type of electrochemical cells. Similarly, it also generate electrical energy from chemical energy by a process called as redox reaction, by a spontaneous redox reaction. Here electrical energy produces from chemical energy by a spontaneous redox reaction. Spontaneous redox reaction. For example, if there is zinc, this is copper. So it will looks like this. Zinc, so this is an electrocell formula. Zinc sulfate, copper sulfate, Cu. So this is the electrochemical cell formula. So galvanic cell is nothing but is also called as voltaic cell, in which it generates electrical energy from chemical energy, which is followed by due to one spontaneous redox reaction. If the electrical energy is produced from chemical energy, that is called as galvanic cell. So this is what galvanic cell according to your syllabus. Now next we are moving on to standard electrode potential concept, which is very important concept in your syllabus. Standard electrode or potential. Standard electrode. This is also called as SEP. Standard electrode potential means what? Generally, in an electrochemical cell, okay, electrochemical చూసినప్పుడైతే generally we dip electrodes in the electrolytic solution. For example, this pen is an electrode. If this is a beaker, contains solution that is electrolytic solution. Always there is an interaction between electrode and electrolytic solution. Due to this reason, there is a presence of what? There is a presence of potential difference. There is a presence of potential difference between electrochemical cell. There is a presence of what is that? Electrode potential. So there is the existence of potential difference between electrode and electrolytic solution. For example, this is a beaker and this is a beaker. This is the electrode, this is the electrode, this is a solution. So due to the interaction of these two, electrode and electrolytic solution, there is a potential difference will be generated. So the potential difference between electrode and electrolytic solution at standard conditions, especially the standard conditions are at approximately 298 Kelvin temperature, 1 atmosphere pressure and 1 molar concentration of electrolytic solution. So these are the standard conditions. at standard conditions. So if standard electrode potential is defined as the potential difference that existing between electrode and electrolytic solution at standard conditions with reference to standard hydrogen electrode, with reference to standard hydrogen electrode. So I already said there is a potential difference between electrode and electrolytic solution. If the potential difference exists at a standard condition with reference to standard hydrogen electrode, that is called as standard electrode potential, which is generally denoted as E bar, E dot. E dot is a formula or a unit generally or a term used for the standard potential. So E dot is used, the formula to calculate standard electrode potential is E cathode minus E anode. E cathode minus E anode. So this is a formula used for calculation of standard electrode potential. And I already said standard electrode potential means electric potential or potential difference at standard conditions with reference to standard hydrogen potential. Now what is mean by standard hydrogen electrode? So now we are moving on to S standard hydrogen electrode. What is meant by standard hydrogen electrode? Standard hydrogen electrode is nothing but it is a type of reference electrode. In the electrochemistry we always use it to use lot of terms such as standard electrode, reference electrode, working electrode, indicator electrode. In such a reference electrode is there. One such a reference electrode is called as standard hydrogen electrode. So standard hydrogen electrode is nothing but, this is a standard hydrogen electrode. There is a beaker. This is electrolytic solution of hydrogen ions. Electrolytic solution of hydrogen ions at 1 molar concentration and 1 atmospheric pressure. So this is a solution of hydrogen ions whose concentration is 1 molarity and pressure is 1 atmosphere. Now there is an electrode which is dipped in the hydrogen. This electrode is platinum electrode. So if the platinum electrode is dipped in the electrolytic solution of hydrogen ions at standard conditions such as 1 molarity and 1 atmosphere pressure, this is called as standard hydrogen electron. It is an example of reference electrode. So there are many types of reference electrodes are there. So the classes are, reference electrodes are many types. Reference electrodes are many types. One is standard hydrogen electrode. Second one is saturated calomel electrode. Third one is standard AG or AgCl electrode. So these are the 3 different types of reference electrodes used in the electrochemistry, especially in the electrochemical cells. This is all about electrochemical cells. Now we are moving on to one more important concept, that is electrochemical series. What is mean by electrochemical series? In the name itself, series in the sense arrangement. So electrochemical series in the sense it is defined as arrangement of metals according to their standard electrode potentials. Simple. Electrochemical series is nothing but arrangement of metals based on their standard electrode potential. So these electrochemical series is also called as activity series, which is very important to you. Remember this. I am again stressing activity series. Electrochemical series is also called as activity series. It is defined as arrangement of metals in an order based on the potential, based on the standard electrode potential of the metal. For example, metals, let us consider metals A, B, C, D. These are the A metal, B metal, C metal. It is an arrangement. So A metal has, in the electrochemical series, A is greater. According to the standard electrode potential of A is more. If standard electrode potential of A is more, means A metal is more reactive. Is more reactive in nature and more reducing property. More reducing. Simply by observing the electrochemical series, the metal with more amount of standard electrode potential is considered as more reactive, more reducing power will be there. So this is the simple and very shortcut method for electrochemical series. Now we are moving on to another topic, that is EMF. I think you might know this concept earlier. EMF stands for electromotive force. Electromotive force. Electromotive force. What is meant by electromotive force? Electromotive force is simply the potential difference that existing between electrode and electrolytic solution. This is nothing but electromotive force in the maximum potential difference. The maximum potential difference that exists between electrode and electrolytic solution when there is no current flow. So that is called as electromotive force. It is defined as maximum potential difference. Maximum potential difference between electrode and electrolytic solution when there is no current flow. So for example, this is the one beaker, this is one beaker, electrode, electrolytic solution. So there is a potential difference V. There is no current in this. So then the potential difference that existing in the electrochemical cells when there is no chance of current, or when there is no flow of current, is called as electromotive force. So this is called as electromotive force. So simple. And next we are moving on to one more important concept, that is batteries and fuel cells are there. And I think there is no charging in the camera, so we will move into next thing. So just a minute, I will back in a few seconds. కెమెరా బ్లింక్ అవుతుంది. So welcome back students, and this is electromotive force. Electromotive force means the maximum potential difference that exists in between electrode and electrolytic solution when there is no flow of current in between the electrode, in between the two cells. So this is called as electromotive force. Now we are moving on to batteries. What is meant by battery? Batteries means simple. The batteries are the devices that have the ability to store the chemical energy. That means batteries are the devices that has ability to store the chemical energy. That chemical energy can be converted into electrical energy upon purpose. According to the purpose, the chemical energy, whatever it is stored in the battery, can be converted into electrical energy. So batteries are defined as devices that stores stores chemical energy and converts into electrical energy upon purpose. Convert into electrical energy. It's called as batteries, and the batteries plays very important role in our daily life. Again, batteries are classified into two types: primary batteries and secondary batteries. What are primary batteries? So primary batteries are the batteries in which the chemical energy once converted into electrical energy which cannot be recharged or reused. అంటే ఒక్కసారి ఇక్కడ ఉన్నటువంటి ఎనర్జీ కంప్లీట్ అయిపోతే మళ్ళీ దాన్ని రీఛార్జ్ చేయలేం. those batteries are called as primary batteries. So primary batteries are the batteries once they use can't be recharged. Where secondary batteries are batteries once the chemical energy is utilized for the conversion of electric energy, they can be recharged multiple times. Secondary battery, it can be recharged multiple times. So batteries are classified in two types: primary battery, secondary battery. Primary battery means it is a device in which chemical energy is stored for the conversion of electrical energy, but once the chemical energy is utilized for the conversion of electrical energy, it cannot be reused or recharged again. But in the case of secondary battery, it can be recharged or reused multiple times or million number of times. So this is all about battery. The best examples for the battery is lithium ion batteries. Nowadays we are using it. Lithium ion batteries are there, and also nickel cadmium batteries are also there. Nickel cadmium batteries. So lithium ion batteries and nickel cadmium batteries are generally used batteries these days. Now this is all about batteries. Now we are moving on to one more important thing, that is fuel cells. Fuels are nothing but, I already said, electrochemical is a device that converts chemical energy into electrical energy. There are different types of electrochemical cells. One such electrochemical cell is fuel cell. So fuel cell is nothing but, it is an electrochemical cell. But it converts the chemical energy of fuels such as hydrogen. Fuel cells are nothing but, it uses chemical energy of fuel such as hydrogen, and oxidation energy of oxygen. So fuel cells are the devices that generally uses chemical energy of fuels such as hydrogen and oxidation energy of O2 to produce electrical energy, water and byproducts. To produce electrical energy, water and some other byproducts. Fuel cells are nothing but, these are the important fuel cells which are very important, because fuel cells only releases electricity at the same time as water. So water is an eco-friendly nature. That's why when we compare with the other electrochemical cells, they will pollute the environment in a certain extent, because they produce energy. Apart from that energy, they also produce some harmful substances. But in the case of fuel cells, it only produces electrical energy and H2O byproducts. These are eco-friendly. That means which are very friendly to the atmosphere. They cannot cause any kind of adverse effect onto the atmosphere. So this is all about fuel cells. So fuel cells are nothing but electrochemical cells which uses chemical energy of fuel. అంటే హైడ్రోజన్ యొక్క ఫ్యూయల్ ఎనర్జీ దట్ ఈస్ సింప్లీ క్యాలరిఫిక్ వాల్యూ. ఆ క్యాలరిఫిక్ వాల్యూని ప్లస్ ఆక్సిడేషన్ ఆఫ్ ఆక్సిజన్ అంటే ఆక్సిజన్కి ఉన్నటువంటి కంబషన్ ఎనర్జీని యూజ్ చేసుకొని ఎలక్ట్రిసిటీని జనరేట్ చేయడం. సో దిస్ ఈజ్ ఆల్ అబౌట్ ఫ్యూయల్ సెల్స్. అమాంగ్ ఆల్ ద డిఫరెంట్ టైప్స్ ఆఫ్ ఎలక్ట్రోకెమికల్ సెల్స్, the fuel cells are more affordable and more expensive, and also they are very important in terms of reduction of global gas emissions also. And And now in this we have discussed about electrochemical cells. We know that what is electrochemical cells? Simply, electrochemical cell means device, and it 4 types are there. And next, what is known as a galvanic cell? Simply, it is nothing but by spontaneous redox reaction and standard electrode potential at standard conditions with reference to standard hydrogen electrode. Standard hydrogen electrode means platinum. This is one of the important questions for ECET. ECET, H plus reference electrode. This is types of reference electrodes, and this is electrochemical cell is nothing but arrangement of metals based on the standard electrode potential. It is also called as activity series, and this is all about electromotive force, which is nothing but maximum potential difference when there is no current. Remember this. Batteries, primary, secondary, and different types of battery. This is all about fuel cell. So finally we have completed all the portions and all the syllabus of ECET, and very good luck for your exams. All the very best for the students. And finally I am signing off, myself Chandra Prakash again, and Faculty of Chemistry, ECET. This is Ask Engineering Academy located Dilsukhnagar. If you are anybody interested to join these institutions, you can directly contact the details provided in the description box below. So this is the best institution forever I have witnessed, and they are imparting quality education for the students at affordable prices. So it is not a business, especially the faculty or the director is really passionate to the teacher to provide a quality education for all. So this is all about ECET syllabus completed. So now my responsibility is completed. Now your work and your responsibility will start. So all the very best for the students. Thank you so much.